The 1980s wasn't just a decade of big ideas, it was the era when excavators went beast mode. Manufacturers unleashed machines so huge, so powerful, and so far ahead of their time that the entire construction industry had to stop and stare. These weren't just excavators, they were earth-moving monsters capable of ripping through rock, swallowing mountains, and doing the impossible. Get ready, because these are the 10 most powerful excavators from the 1980s that shocked the industry to its core. Number 1. Bucyrus Erie 1850B Big Brutus. By the time the 1980s arrived, the Bucyrus Erie 1850B, popularly known as Big Brutus, had already cemented itself in the mining world as one of the most unbelievable engineering achievements ever created. Even though it was built in the 1960s, it continued influencing the industry well into the 1980s because no other machine came close to matching its intimidating scale and operational dominance. Standing nearly 160 feet tall, stretching 150-plus feet in length, and weighing around 5,500 tons, Big Brutus wasn't just a machine, it was a moving industrial landmark. With a massive 90-cubic-yard bucket, it could scoop enough material in one pass to fill a small house, a capability that stunned those who worked around it. In the 1980s, as hydraulic excavators were beginning to rise, mining companies looked back at Big Brutus as the ultimate symbol of the electric shovel era. A reminder of a time when manufacturers pushed the limits of steel, electricity, and mechanical power with almost no boundaries. What shocked industry engineers most was how Brutus forced mines to redesign their entire workflow. Haul roads, benches, overburden removal strategies, and even truck fleets had to be adapted around the shovel's extreme output. If the supporting fleet wasn't scaled properly, Big Brutus would simply outdig everything around it. Its massive electric power system, rope shovel mechanics, and long-life design proved that machines of the past were built with almost indestructible durability. Even decades later, mines used Big Brutus as a benchmark of what true heavy mining looked like. Many believe that if Brutus was built with modern hydraulics and electronics, it would still outperform most large excavators today. The legacy it carried into the 1980s made it a frightening and awe-inspiring example of just how far mining machinery could evolve. Number 2. Demag H485. While the 1980s are remembered for giant electric shovels from Bucyrus and Marion, one machine stood out as a revolutionary force from Europe, the Demag H485. This wasn't a rope shovel or a dragline. It was a true hydraulic mining excavator, one so large and powerful that it shocked engineers who believed hydraulics had physical limits. The H485 was one of the first hydraulic excavators big enough to challenge the dominance of mechanical shovels in large open-pit mining operations. What made the Demag H485 groundbreaking was its massive twin-engine power system, advanced hydraulic pumps, and bucket sizes that pushed far beyond what hydraulic machines were believed capable of at the time. Many experts in the early 1980s thought hydraulics could never reach ultra-class productivity because of heat issues, pressure limits, and structural fatigue. Demag proved the industry wrong. The H485 delivered exceptional breakout force, smooth digging motion, faster repositioning, and efficient cycle times that rivaled and sometimes beat electric rope shovels in certain applications. The machine's structural design was also ahead of its time. Demag engineered heavy-duty booms, sticks, and slew rings capable of surviving the intense stresses of mining. Operators praised the H485 for its smooth hydraulic response and powerful digging ability, which allowed it to work effectively in both hard rock and overburden environments. Unlike rope shovels, it could be relocated relatively easily, giving mines far greater operational flexibility. By entering major mining markets such as Canada, South Africa, and Australia, the H485 proved that ultra-large hydraulic excavators were not only viable but economically competitive. It opened the door for even larger hydraulic machines like the RH series, Hitachi EX series, and later Liebherr's massive backhoes. The Demag H485 didn't just shock the industry, it changed the entire direction of mining machine evolution, setting the stage for the hydraulic mega excavator era. Number 3. Komatsu PC800 series. Komatsu's PC800 family became one of the most transformative excavator lines of the early 1980s. At a time when rope shovels still ruled large open pits, hydraulic excavators were mostly seen as mid-sized, flexible machines meant for construction and selective digging. But Komatsu pushed against that stereotype by scaling its hydraulic technology upward, showing the world that hydraulic power could challenge the mechanical giants. Machines like the PC800 introduced new expectations for what a large hydraulic excavator could do: smoother control, faster cycle times, better digging precision, and far more mobility than electric shovels. The PC800 series shocked the industry because it filled a productivity gap that mine operators had always struggled with. Rope shovels were incredibly powerful but required electrical infrastructure and were expensive to relocate. Small to mid-sized excavators were flexible but lacked the bucket capacity needed for true mining scale production. The PC800 landed right between these extremes, big enough to load large trucks but still mobile enough to be moved around the mine with far lower relocation cost. Komatsu's improvements in hydraulic efficiency, energy-saving controls, and operator comfort made the PC800 one of the first machines that could realistically replace older mechanical excavators in certain environments. Operators praised its precision, the ability to dig selectively, clean benches efficiently, and work in areas where a rope shovel simply couldn't fit. By the late 1980s, the success of the PC800 series convinced many mining companies that hydraulic excavators were not just supplemental machines, they were the future core tools of mining fleets. This shift started in the 1980s, and Komatsu's heavy PC series machines were the catalysts behind it. Number 4. Hitachi Large Class Excavators. The 1980s were the decade when Hitachi proved to the world that Japanese engineering could compete with Western mining giants. Most people today know the company for its massive EX series monsters like the EX2500, EX5500, and EX8000. But the foundations for these giants were built in the early 1980s when Hitachi's large-format hydraulic excavators began entering international mining markets. These machines brought a new combination of high reliability, advanced hydraulics, improved fuel efficiency, and better operator ergonomics. What shocked the industry during the 1980s was the rapid improvement curve. While many Western manufacturers were relying on older, tested but aging designs, Hitachi was introducing modern hydraulic systems with extremely smooth control and impressive uptime. Mines especially loved Hitachi machines for their reliability. Many operated across Asia and Australia in extremely harsh conditions with minimal breakdowns. This consistency helped Hitachi gain a reputation much faster than anyone expected. Hitachi also embraced modular design and easier maintenance access, something that older machines lacked. Their excavators offered improved diagnostics, easier engine access, smoother swing systems, and more refined power management. This allowed Hitachi machines to maintain production levels very close to rope shovels in some applications, but with the added advantage of mobility and lower operating cost. In the 1980s, Hitachi's international success caught many traditional OEMs off guard. Suddenly, mines were choosing Japanese-built mega excavators over long-established Western brands. This competitive pressure accelerated innovation across the industry and effectively launched Hitachi into the mining superpower category, a position it still holds today. Number 5. O&K RH series. The RH series hydraulic excavators from Orenstein and Koppel, O&K, later absorbed into Terex, represented one of the boldest engineering pushes of the late 1970s. Machines like the RH170, RH200, RH340, and eventually the RH400 would go on to become some of the largest hydraulic mining excavators ever made. But even in their earlier forms during the 1980s, these machines shocked the global industry by proving that Europe could produce ultra-large hydraulic excavators capable of competing directly with the best from Japan and the US. The RH series was built with extreme durability in mind. Heavy steel structures, massive boom and stick assemblies, dual engine options, and high-flow hydraulic systems that delivered unbelievable digging power. These machines were engineered specifically to load ultra-class haul trucks efficiently, with bucket capacities far larger than what was common for hydraulic excavators of the era. What shocked many engineers was the scale at which hydraulic technology was expanding. Until then, most experts believed hydraulics were great for mid-size excavators but unsuitable for truly massive mining workloads. O&K shattered that assumption. Their RH machines demonstrated that hydraulics could deliver the required breakout force, bucket capacity, and cycle speed needed for large-scale iron, coal, and copper mining. The RH series also pushed OEMs to improve their build quality, hydraulic cooling, and structural engineering. Many mines found the O&K excavators so productive that they began replacing older mechanical excavators entirely, shifting toward fleets centered around hydraulic backhoes. The European engineering excellence showcased by O&K in the 1980s laid the groundwork for some of the most iconic mining excavators ever built, and the RH series became a global benchmark for hydraulic power and reliability. Number 6. Komatsu PC200 series. While the PC200 series may not seem like a mega mining machine by today's standards, its importance in the 1980s cannot be overstated. This excavator family became a technological milestone that enabled the entire hydraulic excavator revolution. The PC200 was one of Komatsu's flagship models in the early 80s, introducing cutting-edge hydraulic improvements that would become the foundation for scaling excavators into the 400, 600, 800, and even 1000 class sizes later on. What made the PC200 truly shocking to the industry was not its size, but its hydraulic efficiency. This machine introduced more responsive load-sensing systems, better stability in neutral, reduced energy loss, and smoother operator control. These innovations might sound small, but in practice, they transformed the way excavators behaved. Operators found the PC200 easier to control, more fuel-efficient, and significantly more productive per hour than earlier hydraulic machines. And most importantly, these improvements could be scaled upward, allowing Komatsu to build much larger mining-class hydraulic excavators later in the decade. The PC200 became the excavator that convinced many mines and contractors to trust hydraulics over older mechanical systems. Engineers realized that hydraulic excavators could finally offer the durability, precision, and reliability needed for industrial-scale work. The machine also gained popularity because of its lower maintenance cost, improved serviceability, and strong dealer support. In the 1980s, as the competition between rope shovels and hydraulics intensified, the PC200 silently laid the blueprint for a new era. It proved that hydraulic efficiency was not just a feature, it was the key to building the massive mining-class hydraulics that would soon dominate global operations. Without the PC200 series and its revolutionary controls, the giant excavators of the 1990s and 2000s might never have existed. Number 7. Caterpillar's large mining loaders. Although wheel loaders are not excavators in the strictest sense, Caterpillar's massive 992 series mining loaders played a critical role in shaping the industry's view of productivity in the 1980s. These machines shocked mine planners because they were designed to match the output of huge excavators and rope shovels, forming an integrated production ecosystem. The 992 and its related models had enormous bucket capacities, powerful drivetrains, and unmatched durability, making them the preferred tools for loading ultra-class haul trucks in many operations. In the 1980s, the idea that a wheel loader could compete with a large hydraulic excavator or even a rope shovel seemed unrealistic. But Caterpillar proved otherwise. Their loaders delivered extremely fast cycle times, allowing mines to move staggering amounts of material per hour, often outperforming poorly matched excavator-truck combinations. This forced mines to rethink engineering fundamentals. Productivity wasn't just about how strong your excavator was, but how well every machine in the production chain matched each other. Caterpillar's loader lineup also shocked the industry with its reliability. Mines found that the 992 series often operated longer hours with fewer breakdowns, thanks to robust transmissions, massive tires, and simplified mechanical systems. These machines were designed for harsh mining conditions, capable of operating in intense heat, freezing climates, and abrasive environments with minimal performance loss. Another surprising factor was the loader's versatility. Excavators and shovels excelled at face loading, but loaders could travel, reposition, and manage multiple tasks in the mine. This mobility made them indispensable for cleanup, stockpiling, and high production loading. For many mines in the 1980s, Caterpillar's mining loaders were the secret weapon that helped them achieve record-breaking production. Number 8. LeTourneau L2350 Lineage. Long before the 2000s era hype surrounding the massive L2350, its engineering lineage was already influencing the mining world in the 1980s. LeTourneau's philosophy was simple: build loaders so large and powerful that they could reshape how mines planned their operations. Even the earlier versions of these ultra-class loaders stunned the industry with their size: towering frames, huge buckets, articulating bodies, and electrically driven systems that gave them almost limitless torque. By the 1980s, LeTourneau loaders were becoming essential tools in large open-pit mines, especially in coal and iron operations. They could load enormous haul trucks in just a few passes, achieving production levels that previously required much larger fleets. Their massive scale forced mines to reconsider everything: haul road width, bench size, maintenance shop dimensions, even tire supply chains. Many mines realized that choosing a machine this large came with entire logistical consequences. The machines also introduced unique engineering challenges. Their tires were gigantic and expensive, requiring specialized supply chains. Their torque and articulation placed huge stresses on drivetrains, demanding advanced lubrication and cooling systems. But despite these challenges, mines loved the machines because of their insane productivity. Even with massive operating costs, they were often cheaper per ton due to unmatched cycle efficiency. Perhaps the most shocking impact came from how these loaders influenced global mining strategy. Their presence showed that pushing equipment size upward was not only possible but economically advantageous, leading to even larger excavators, haul trucks, and loaders in the decades that followed. The L2350 lineage was proof that bigger is better wasn't just a slogan, it was the future of large-scale mining. Number 9. Big Muskie and the last era of super draglines. Even though Big Muskie, the Bucyrus Erie 4250W, was built earlier in the 20th century, it continued to influence mining operations deep into the 90s. As the largest dragline ever constructed, it became a symbol of raw mechanical dominance. The machine weighed over 13,000 tons, carried a 220 cubic yard bucket, and could remove more overburden in a single swing than entire fleets of hydraulic excavators. This staggering level of productivity forced the industry to respect draglines long after newer machines became available. In the 1980s, the mining world stood at a crossroads. Hydraulics were rising, offering flexibility, selective digging, and better mobility. But draglines like Big Muskie proved another truth. In massive surface mines with soft to medium overburden, no machine could match the cost per ton efficiency of a super dragline. They operated on electricity, consumed no diesel, and could strip thousands of tons per hour with consistent, reliable swing cycles. Engineers were shocked by Big Muskie not just because of its size, but because of its operational economics. Despite huge upfront cost, draglines offered decades of service with relatively low running cost. The machine became the gold standard for what extreme capacity mining looked like. As new excavators emerged in the 1980s, their performance was always compared to the legendary output of Big Muskie. Big Muskie also influenced pit design. Mines that used draglines had to be planned around their massive walk paths, digging geometry, and swing radii. These limitations shaped entire landscapes. Even as the world moved toward hydraulic mega excavators, the ghost of Big Muskie loomed over the industry as a reminder of what was once possible when machines were built with virtually no size restrictions. Number 10. P&H Komatsu 4100 Class Evolution. Although the world-famous P&H 4100 class electric rope shovels rose to prominence in the 1990s and 2000s, their engineering roots and the design breakthroughs that made them possible were planted in the 1980s. During this decade, P&H was experimenting with structural upgrades, more efficient electric systems, better crowd mechanisms, and stronger booms and dippers. These incremental but important improvements paved the way for the ultra-class shovels that would later dominate global mining operations. What shocked the industry in the 1980s was the realization that electric rope shovels weren't going away. They were evolving faster than ever. For years, many believed that hydraulics would completely replace electric shovels. but P&H proved that rope shovels could be modernized. Their heavy-duty structures, long service life, and exceptionally low cost per ton made them essential for high-capacity mines. By refining electric control systems and structural components, P&H set the stage for the 4100 series, which would eventually become some of the world's most iconic loading machines. The 1980s models demonstrated improved bucket capacities, smoother swing systems, and better energy efficiency. Mines noticed that these upgraded rope shovels could operate for decades with the right maintenance, a lifespan far longer than most hydraulic excavators. The evolutionary steps P&H took in the 1980s shocked the industry for one major reason. They proved that the race between hydraulics and rope shovels wasn't one-sided. Instead, both technologies were advancing rapidly, each suited for different mining conditions. This competition pushed the entire industry forward, resulting in the massive, ultra-class machines we see today. These machines didn't just move dirt, they moved the entire industry forward. The 1980s created giant machines so far ahead that even today's excavators still follow the groundwork they laid. If you enjoyed this journey into the era of unstoppable power, hit like, subscribe, and tell me which excavator blew your mind the most. Thanks for watching, and stay tuned, because the next video digs even deeper into the legendary machines that shaped our world.